And we're live. All right, so.
Yes!
Let's
go!
Coming to you live from downtown Morrison. It's Mr. Mac. Woo! All right,
Mr. Mac!
That's right. Thank you. I've got a great show planned for you today. All right, so. Transversals. We had a couple theorems we needed to prove from last time. What angles were we going to prove that were congruent and or supplementary? I suppose it wouldn't be and or, but. Did we already do alternate interior angles theorem? Yeah, we did.
I remember doing this in like 8th grade.
Wonderful. Class. Alternate interior angles theorem. Did we already prove that 4 is congruent to 6 or 3 is congruent to 5? Yeah. I believe we did. What about same side? Do we do an example with same side interior angles? No? Okay, let's prove that now. What? No, what'd you say? I think it was. Would someone like to confirm that?
It was.
Did anybody even attempt this?
I'd like to confirm.
Yes, I did. Oh, not that part.
You guys attempted this,
I confirmed it was.
but you did not attempt to prove any of the theorems I said? Oh, no.
I know. Which theorem do you want one right now?
All right, let's do same side interior real quick. So, somebody give me an example of same side interior angles based on this diagram. Zayden. 4 and 5, same side interior, right? They're in the same side, they're in the interior. Cool?
Cool.
So, we're going to prove 4 and 5 either congruent or supplementary. Which do you think they are? Well, I think supplementary would make sense. We know 4 and 6 are the same thing by alternate interiors, right? So those two are congruent. So 5 must be supplementary to it, right? Because these guys are a linear pair. I basically just did the proof right there. Here it is. So our goal is to prove, that's with 1 O, angle 4 is congruent to angle 5. That is our goal. Oh, sorry, not congruent. Angle 4 is supplementary. All right, so let's prove those two supplementary. Here's what I need. I need something with 4 and 5 together, right? Now, there is no direct connection to 4 and 5 because they're on different intersections. All right, so we are allowed to use vertical angles theorem. Who can tell me what vertical angles theorem is? Danny.
When two angles are 180.
Nope.
90.
These two angles are the same, these two angles are the same, right?
Yes, that's right.
So if you look at 4, by vertical angles we know it's congruent to 2, right? Same thing with 1 and 3. Same thing with 5 and 7, same thing with 6 and 8. So we're allowed to use vertical angles theorem to prove that 4 and 5 are supplementary. It's a V. We're also allowed to use linear pair theorem. What does linear pair theorem say? If we have a linear pair, what?
They are supplementary.
They are supplementary. So like 1 and 4 are a linear pair, right?
Yes,
They're two angles on a line, just two. And so they're going to be supplementary by linear pair theorem. So that's useful because we want to prove 4 and 5 supplementary. So we can get a statement with something and something, 4 and something are supplementary. Maybe we can switch out that 5, right? The last thing we're allowed to use is corresponding angles postulate, which says that corresponding angles are going to be congruent if the lines are parallel, which I'm telling you they is. All right, so 4 and 8 are corresponding, so they're congruent. Okay. So how would you go about doing this? There's lots of ways. We want to get 4 and 5 together. So tell me something about 4 first. Zayden. Okay, that's one way to do it. So 4 is congruent to 8. How do we know 4 and 8 are congruent? C, A, P. They're corresponding angles, right? They're corresponding angles. So they're congruent. Cool. Well, we now have 4 and 8 together. What do we know about 5 and 8? Do they have a relationship? Somebody else.
Can you blow it up? They are. Oh yes, they're a linear pair.
5 and 8 are a linear pair. So let's write that. Angle 5, angle 8 are a linear pair. A linear pair, which means they're supplementary, right? So they're sup by linear pair theorem. Could you write they're a linear pair by definition? Yes. Therefore, if we use linear pair theorem, they're supplementary? Sure. Sure. We're cutting to the chase. So 5 and 8 are supplementary by linear pair theorem. So if we know 5 and 8 are supplementary, and we know 4 is the same thing as 8. Remember, when we have the word congruent, it means same dumb thing. So 4 is 8. They're the same dumb crap. So wherever we see a 4, we can switch it out for an 8. And vice versa. There's an 8. If we switch that out for a 4, we get 5 and 4 are supplementary. Isn't that what we want? So we're going to use substitution now. So instead of writing 5 and 8 are supplementary, I'm going to take this statement. I'm going to switch out the 8 with the 4. When we switch stuff out, what do we call that? So they are supplementary. And we know that by substitution, right? 5 and 8 are supplementary. We got that from linear pair theorem. We now know 5 and 4 are supplementary because we can substitute 8 for 4, right? They're the same dumb crap. So now we win, right? The swag box. That's the proof. 5 and 4 are supplementary because 4 and 8 are congruent and 5 and 8 are supplementary. So 4 and 8 are the same thing. Instead of saying 5 and 8 are supplementary, I can say 5 and 4 are supplementary and I win. Another way to do it. 4 and 1 are a linear pair. So they're supplementary, right? 1 and 5 are congruent by cap, right? So I switch out 5 for 1 and I get 4 and 5 are supplementary. Same dumb thing. How you feel?
I guess.
Yeah? You can also do 4 and 3 are supplementary. 3 is congruent to 5 by alternate interior angles theorem. Switch them out. All right. Let's do another one. We did same side interior. We've done alternate interior. Let's do alternate exterior. Give me an example of alternate exterior angles. Jess. 1 and 7. They're alternate and they're on the exterior, and they're not a linear pair like 1 and 2. Cool. So our job is to prove 1 and 7 are congruent. And they will be. Right, they wouldn't be supplementary because 1 and 2 are supplementary, and 2 is not the same thing as 7, right? So it can't be supplementary, it must be congruent. So given, I guess we should write before we do a proof, right? The only thing that this relies upon is that the lines are parallel. So let's call those lines line L and line M. Cool. Stop working on the homework. Eyes up here. You're going to have to do this on your quiz.
Wait a second.
Today,
Just be quiet.
I can confirm.
Yeah, it's going to be Friday. All right, so given these two are parallel, we're going to prove 1 and 7 are congruent. Well, the problem is that 1 and 7 are separated, right? They're not in the same intersection. If they were in the same intersection, pretty easy to do, right? Linear pair, or I'm sorry, vertical angles, done, right? 1 and 3, super easy. Prove 1 and 2 are linear pair, or supplementary. Linear pair theorem, done, right? But because they're separated on different intersections, we got to get creative to get there. It's going to take some steps to combine to get them together. Vertical angles only works within angles that are in the same intersection, right? Linear pair, same thing, same intersection. So we're going to have to use cap at some point to bridge the gap between 1 and 7. 1 corresponds with 8, right?
Yeah.
Okay. So 1 and 8 are the same thing, right?
No.
Why aren't they?
I can.
Zayden.
1 and 5 are corresponding.
1 and 5 are corresponding. Top left, top left.
Yeah.
1 and 5 are the same thing. So 1 and 5 are the same thing by corresponding angles postulate. What do we know about 5 and 7? Vertical angles. So 5 is the same thing as 7. So 1 is 5, 5 is 7, therefore 1 is 7. That's going to be the proof, okay? So let's write 1 is congruent to 5. How do we know 1 and 5 are congruent? Say it again. Everybody. There we go.
Angles.
By cap.
Cap.
Corresponding angles postulate. What do we know about 5 and 7? So they're congruent by vertical angles, right? Scissor theorem. Your words, not mine. So now we know 5 is the same thing as 7, and we want to get 1 and 7 together. So I'm going to switch out the 7 for the 5. And the way I'm going to do that is by substitution, right? So instead of writing angle 1 is congruent to angle 5, I'm going to write angle 1 is congruent to angle 7, which is what I wanted, right? And I did that by substitution.
Will we be getting like a study guide type thing?
Yes. Tomorrow we always get a review. Yes. We review on Thursdays. Ta-da. How do we feel about these proofs?
That's so good.
Good. I need to work on it.
Okay. Do we see it now? If you didn't see it before, the question is, do you see it now? 1 and 1 and 5 are congruent by cap.
It's like that.
5 and 7 are congruent by vertical angles.
Is that all
Boom.
we're gonna have to do?
There's other stuff you're gonna have to do in the quiz tomorrow.
Like to see, like to show how what angles are congruent.
This is the proof for those two angles being congruent. Yes.
Like so, if the question asks, find 1 and 5 being congruent. Prove that angle 1 is congruent to angle 5. That's all you're gonna have to do.
Corresponding angles postulate. Done.
Yeah.
Yeah, but I wouldn't ask you to do that one because that's super easy. I would say prove 1 is congruent to 7.
Can't you give us an easy one?
No. Waste of your time, waste of mine. Another way to do this. 1 is congruent to 3 by vertical angles, right? 1 and 3 are congruent by vertical angles.
My substitution.
And 3 and 7 are congruent by cap.
Oh, jeez.
Switch them out, right? Another way to do it.
So substitution?
Yeah.
That's right.
I get it now.
All right, so we've done alternate external. Let's do same side external. How about purple? Autumn, give me examples. Give me an example of two same side external angles. Mm-hmm. They're on the same side and they're external. 2 and 7. All right, so first of all, are we going to prove these congruent or supplementary? Supplementary, because you know that 2 corresponds with 6, so they're the same, right? And 6 and 7 are supplementary. So if 6 and 7 are supplementary, then 2 and 7 must be supplementary. And that's the proof. Okay, so we're going to prove them supplementary. So let's do that. So our goal is to prove, and that's with 1-0, that angle 2 is supplementary to angle 7. How do we want to write it? Zoom out again.
So, wait, for this diagram, okay.
For this diagram, yep. Your diagram might be different. I'm just choosing 2 same side external angles, right?
Yep.
Cool. All right, so I'm going to prove 2 and 7 are supplementary. How do you want to do it? First of all, we should state some facts about angle 2. What do we know about angle 2?
It is equal to congruent to angle 6 by cap.
Okay. That's one way to do it. Cool. So 2 and 6 are the same thing by corresponding angles postulate. Again, same relative location. They're both in the top right corner of their respective intersections, so they are congruent because the lines are parallel. All right, so 2 and 6 are the same. What do we know about 6's relationship to 7? Is it enough to be able to close the deal? Zayden. 6 and 7 are a linear pair. Check it out right there. Linear pair. On the same line, they're both on the transversal, right? And so 6 and 7 are a linear pair. So we know that angle 6 and angle 7 are supplementary by linear pair theorem. Last week we would have had to say they're a linear pair by definition. Look at them, right? There they are. And therefore, 6 and 7 are supplementary by linear pair theorem, right? We can't use linear pair theorem unless we're talking about linear pairs. So you have to establish that they are. But for now, we're going to say, look, everyone knows they are.
I put 8 and 7.
Save a space. Numbers are hard. So now we know 6 and 7 are supplementary, and we have a connection here. 6 and 7 are supplementary. We know that 6 right here, same as 7? Wait, what? Can we do something with this? Two is the same thing as 6, right? So we're going to switch out 2 for 6. Wait, why would we do that? Because that's our goal, right? Last time we did it differently. But it's the same dumb crap. So instead of writing 6 and 7 are supplementary, I'm going to write 2 and 7 are supplementary. Which is what they wanted. Yep, I substituted them out, right? I switched them out. Is everybody understanding subs better now? Okay, good. Thank you. Questions on that? All right, we're going to put that away. Get out the homework. Our plan today is to do the little bit of homework that you totally did. A little bit in class. And then the rest is going to be on you for tomorrow. And then we're going to look at grades, because I know some of you are concerned about them, which is good. About time.
Hang on. Question.
What?
Did you tell the other class that it wasn't due till Thursday?
What?
The homework.
This thing? I think so, yeah.
Because you didn't tell us that.
Oh, oops. Probably because you guys didn't complain when I assigned it. So I didn't think about telling you it. Yeah, go ahead. It's not here. You are great people. The best people.
Are we your best class?
I'm gonna look at my grades real quick.
What's your best class?
Look at your grades when we're done. My best class?
Yeah.
None of the above.
Best class.
All of you are lacking in your own special way. Oh no! Give me that. Give me it. This is what happens. We have one box for the entire year. Actually, we have 2 boxes now because somebody brought some in.
Frick.
There is no hope. Love me. All right.
That was so great.
All right. So it says BFC and DFE are the same. Sorry, I'm not reading this correctly. Given that measure of angle AFB is the same as the measure of angle EFD. Well, AFB is this guy, and EFD is this guy. Daniel,
Yeah.
have a seat, please.
Alright.
Thank you for tearing apart the box. We do want to think outside of it.
Step box.
Points B, F, and D, and points E, F, and C are collinear. Collinear just means they're on the same line. So if they tell you something's collinear, all they're telling you is, hey, those are actually lines. Katie, what the entire class period you've done this. Come on, bring it back now. BFD, and you're not alone, Zayden. BFD is a line is what they're telling you. That's it. And EFC, a line. The reason they do this is because, like, you know, like AFD is not a line, right? It's easy to see it. But BFD, maybe that's not perfectly straight. Maybe that's bent a little bit, right? It's kind of hard to tell. So they're telling you, no, it is in fact a line. That's a line, that's a line, okay? We just have an X here with a little appendage, okay? State whether each pair of angles is a pair of vertical angles, pair of linear pair angles, or neither.
LPT.
Redundancy is for redundancy. Then tell the angle measure for each. So BFC, that one right there. Let's do that in orange. DFE is this angle. The pink. What do we know about these two angles? They're vertical, right? Scissor theorem. Your words, not mine. So, those two angles are congruent. Now, the beauty is that they told us in the instructions that these guys are 50, which I think most of you guys just read right past.
No, I wrote that down.
Good, wonderful, no one cares. All right, so if these are a vertical pair, then that means this is also 50, right?
LPT.
So we write that these things right here are vertical angles. I will accept scissor theorem as well. Your words, not mine. Which means that they're both 50 degrees. So far, so good? Okay.
Oh, dude, I had the right answer first.
BFA, that's this guy right here, and DFE, these two. Are they congruent? Oh, yeah. Are they vertical? No, no. Are they a linear pair?
Oh, yeah.
There's something.
There's something in the middle. Something in the way she moves, right? The three angles on a line. That's not a pair. That's a trio. Okay? Three's a crowd. Two angles on a line. That's a linear pair. So this is not a linear pair. They are collinear. They are on the same line together, but they're not a linear pair.
The same.
Emphasis on pair, like the fruit. Okay? So neither. Are they congruent? Yes, they are. They're both 50. I don't think you need to write the number down here. As long as I see it in your diagram, you're good. Alex, we doing okay? Yeah, wonderful. Okay. BFC. BFC. Kentucky Fried Chicken. And CFD. This guy. So these two angles. Let's make that one blue. So blue and orange. What do we know about them? Whoops. Oh no.
What the heck?
Oh, there's a button that flips it? I can't tell you how many times I've had to do, like, instead of having a camera like this, I had to put this, like, upside down on my desk and flip it around. Mind blown. Mind blown. All right, cool. We learned some today. Today I learned. All right, BFC and CFD, that's the orange and the blue. What do we know about them? Yeah.
They have to add up to 180.
They have to add up 180 because linear pair says so, because these are, in fact, a linear pair. So they're a linear pair. Now, they do have to add up to 180, right? Because they have to be supplementary is what the words are in the linear pair theorem. We know that means by definition that they have to add up to 180. So if that one's 50, what's this one going to be? 130. All right, so they're 130, and they are a linear pair. Whoops, sorry, I already wrote that down. That was number 3. Number 4, AFE. This angle right here. Let's do that one, I don't know, how about green? And then AFC, like the conference in football. AFC is this angle right here. Now notice this angle is comprised of 2 angles. Right, so by angle addition postulate, I know the whole angle is going to be how much? 100, which is what we're keeping it. That's 100. What about this guy? Is this angle right here, let's make it purple, and the green angle, are they a linear pair? Yeah, they are. That's 1 angle, that's 2 angles, and they make up the entire line, right? So they are, in fact, a linear pair. Which means they add up to what by linear pair theorem? You can't see no more? I can't see no more. Oh, man, these kids. Buy them glasses. Please, go fund me. All right, linear pair theorem. In fact, I'm getting contacts in a couple days for the first time in a long time because, like, doctors are like, you can't have those. You don't take them out and you read music and you don't blink and then your corneas dry out. And I'm like, I hear you. And what you're saying is I should get a new doctor, right? And so I go get a new one. And I don't tell them anything. And they're too dumb to check to see all the scars on my eyes. And so I get them, right? So I'm going to have contacts again, which means I can have these glasses right here for anybody that needs them whenever they need them.
I'm gonna need them.
Autumn, I'm talking to you, okay? Anything's got to be better than nothing, okay? Yeah, I've really walked into this one. All right, so linear pair. All right. Halloween's coming up. And I'm saying, what better costume than dressing up as your favorite teacher? All I'm saying is, it would be hilarious to walk into this room and have everybody looking like me. All right.
All you need is like a goatee.
It's not complicated. All right. So these 2 angles have to add up to 180. So that's 100. What is the green angle? Try again. Good job. I know you did. I know, I'm just messing with you. All right, so they're 80. And they're a linear pair, right? That was BFE, I believe. No, it was, no, it was not. It was AFE and AFC. The rest are on your own. Turn the page. Define each term. What is a transversal? Sounds like a wrestling move, but it ain't. Yeah, give me a definition.
It's the line that cuts across 2 other lines.
Yeah, a line that cuts 2 other lines. Now, we're not specifying whether those lines are parallel or not, because that's true whether they are, or whether they're parallel or they are not. It's just a line that cuts 2 other lines.
Alright, what's the next one?
That's it. Corresponding angles. Are they in the same position? No, they're not. Remember, same position is what happens when we watch that spoopy movie, right? That was gross. They're not in the same position. They're the same relative position. So 1 and 5 are corresponding because they're both, if you look at their relative intersections, both top left corner, right? So corresponding angles.
Yeah.
By the way, angles is spelled A-N-G-E-L or L-E? L-E.
I can't see.
I can't see an Angels.
I can't see and I know.
It's my money and I want it now. Corresponding angles. They are angles that are in the same relative location. Danny, isn't that commercial on like past your bedtime? Like angles that are in the same relative location.
What's that show?
Eric Andre.
George Lopez.
George Lopez. Okay. That is not quite the Eric Andre show. Rest are on your own.
That man's awesome.
Oh yeah, example of corresponding angles. We said 1 and 5, right? I need a definition and an example. Do the best you can on your own, filling out those definitions. Tell which angles are congruent. Number 9. Do it on your own. Which ones are supplementary? Do it on your own.
What a teacher.
I know. So there it is.
Look at your thing. It's already so.
I know. Isn't it beautiful? It's a work of art.
You're gonna have to hang that up in the back of the wall.
At some point, probably yes.
End of semester.
End of semester? Oh, so we have like a semester 1, semester 2?
Yes,
Perhaps
sir.
a clean slate, if you will.
Or like, yeah.
All right, here's what we're going to do. You're going to work on that now, and I'm going to show you your grades, okay? If I call your name and you're not interested in seeing it, good for you. But I do want to show you it because some of you guys graded your quiz more harshly than I would. So congrats to you for almost getting a really bad grade. And some of you guys need to retake some quizzes and tests that you just haven't. And guess what? It's the last week of the semester, or the quarter. So yikes. So I'm going to stop the stream here.